This is part 6A on completing the total effective length for cold air return. In this video we're going to examine return air number 2. Return air number 2, or R2, is going to be designed as a rectangular opening in the side of the return air duct. And this is going to act as the return air inlet for the basement of this house. Now this is an unfinished basement, and therefore the return air can be directly mounted on the return duct. If you did have a finished basement, then it would make a lot of sense to have one or two return airs in a low wall position to draw the cold air off the floor in the wintertime. However, in an unfinished basement, this requirement is not necessary. So for this particular example, R2 is going to be an inlet on the side of our return duct. So in this particular case, we're looking at a rectangular opening. So we need to establish what the rectangular size is going to be. But first off, we need to look at all the effective lengths here and come up with a total effective length. Now, when we examined R1, we found that R1 traveled from the grill down through the studs from the second floor down to the basement, where there was one turn from the stud into the floor joist right here. When the air traveled back to the furnace, to the ductwork, and then traveled through the ductwork back to the furnace. For R2, we have this rectangular duct. And so in looking at the options that we have, if you look at group 3 return branch connections, you'll notice that there is a rectangular duct here, duct fitting D. However, there is two options for duct D. A D1 fitting would be a straight rectangle, but in the end of the duct, whereas D2 would be a straight rectangle, but not in the end, so in other words, inside of the duct. There's quite a difference in the equivalent length, so it is important that we choose the correct one. Since we're planning to put the inlet on the side of the duct, we would have to choose then the D2 fitting, which has an equivalent length of 80 feet. So here is our D, and this would be a D2 at 80 feet. Now for the basement return, because the return is directly connected to the ductwork, there will be no stud to joist or joist to stud fittings, as well as there will be no joist to duct fittings. So as you can see, the stud to joist fitting is blank. Now the turbulence, if you recall, turbulence is the idea that as the air from R2 travels back towards the furnace, it bumps into or intersects with the air coming from R3. So this creates turbulence, congestion, if you will. Every time a return air bumps into an adjacent return air, you have to add 40 feet for the equivalent length. So for R2, you would add 1 times 40 because of R3. The next point of interest in this duct is this transition. Now the transition has the effect of eliminating the turbulence beyond it. So any turbulence or the air from R1, 2, or 3 no longer experiences turbulence in the larger duct. So because R2 only intersects with R3, we would add a 40 for the turbulence. Now, as I mentioned, there is no duct to joist or joist to duct, and so that particular box remains blank. Other than the transition, there are no other duct fittings. And the fitting would typically be an elbow, either side elbow or possibly a riser style elbow or a T or some other type of fitting where the air actually turns. So you can see we've decided that we're going to have our return duct just in a straight line. So there will be no trunk fittings. But as mentioned, we've got the transition, and so we need to account for that transition. And so once again, if we refer to the fittings, the transition in a return air is a K and has an associated equivalent length of 15 feet. So here we have the K fitting, and we can see that that's 15 feet. Now, as well, once the air has gotten beyond the transition, it simply flows through and ends up at the drop duct. And we can look at this diagram here. The air has traveled through the duct. It's now at the top of the drop duct. We are using this B fitting, which has an equivalent length of 35, and the base elbow, which is an equivalent length of 10. And so here we've got the 35 and the B35 and the C10. Now we have to simply measure the actual distance. And so this being a 3/16 scale, I'm simply going to measure from approximately the center of the return drop to approximately the center of our return inlet. And we have here 9 feet. So that's 9 feet of horizontal distance to the top of the drop duct. Don't forget that there is a vertical distance which you have to include. And typically we include the height of the basement. So in other words, if the basement is 7 feet, we would include 7 feet in vertical drop duct length. If your basement was 8 feet, then this would be 8 feet long. If it was 10 feet high, it would be 10 feet long, and so on. In our example, we have 8 feet, and so now we have a total of 8 and 9, so we would have 17 feet. So I can see that there's a slight error here. This should be 17. So now all that's left to do is add all of the equivalent lengths plus the actual length, and you should end up with 197 feet.